The project seeks to revolutionize the fitness industry by harnessing the power of data science. By analyzing a vast data set of exercises, the team aims to develop a system that can provide personalized exercise recommendations. This system will consider factors like target muscle groups, calorie expenditure, and difficulty level to suggest workouts tailored to individual needs and goals. By empowering individuals with data driven insights, the project aims to enhance workout efficiency, increase adherence to fitness routines, and ultimately help people achieve their fitness aspirations. The project's innovative approach involves collecting and analyzing data on a wide range of exercises. By understanding the specific characteristics of each exercise, the system can identify patterns and trends that can be used to generate personalized recommendations. This data-driven approach allows individuals to make informed decisions about their workouts, ensuring that they are selecting exercises that are effective, efficient, and also enjoyable. Ultimately, the goal of this project is to empower individuals to take control of their fitness journey by providing personalized exercise recommendations. The system can help individuals stay motivated, track their progress, and achieve their fitness goals. As technology continues to advance, data-driven approaches like this have the potential to transform the fitness industry and make it easier for people to live healthier and happier lives. So in our evaluation, we have chosen 3 questions. First question is, which exercises are the most efficient for calorie burning? The most efficient exercise for calorie burning are those that engage large muscle groups and elevate your heart rate, like HIIT or high intensity interval training. It alternates short bursts of intense exercise with short recovery periods. We can also do our running. It is a classic cardio workout that burns significant number of calories. Or also swimming. It is a full body workout that is low impact and effective for calorie burning, and a lot of exercises too. Second question. How are exercises grouped based on target muscle groups and difficulty level? Exercises can be grouped based on the muscle groups that they target and their difficulty level. For example, by muscle groups, the chest, back, shoulders, biceps, triceps, legs, core. And by difficulty level, for beginners, we can do body weight exercises, light resistant bands, and low cardio impact. And on intermediate level, we can do moderate weightlifting, moderate intensity cardio, and yoga, and also pilates. And in advanced, if you are an expert already, we can do heavy weightlifting, high intensity interval training, advanced yoga, and plates too. So third question is, what is the relationship between the number of reps, sets, and calories burned? The number of reps, sets, and weight lifted all influence calorie burn. For reps, the number of repetitions of an exercise. More reps generally lead to higher calorie burn, especially when combined with higher intensity. In sets, the number of times you perform a specific exercises. More sets can increase overall calorie burn, particularly when combined with heavier weights. And the weight is heavier weights build muscle mass. which can increase your basal metabolic rate, leading to more calories burned at rest.
So for um, data cleansing or data cleaning ensures that the data set is accurate, consistent, and ready for analysis. Here's a closer look at the main steps. Um, this is our data cleansing process that handles missing values are since missing values are common in data sets and kinetic analysis. In this data set, there are no missing values, but if there were, we could remove rows with missing data if they are few and the data loss is acceptable. We also fill in missing values using techniques like the mean, median, mode, or more complex methods such as imputation, depending on the context of the data. Since no missing values were found, we didn't need to make adjustments. Detecting and removing duplicates is here. The duplicates equals df dot duplicated at some. Duplicate entries can lead to skewed results, especially when counting or summarizing data. We check for duplicates and found none in this dataset. However, if duplicates were found, we could drop them using the df dot duplicated itself. Or we could also add here df equals um, df dot data of the duplicates. But since we have no problem on our data, we didn't put it. Also, standardizing data. Consistency in data formatting is essential, for example. Ensure categorical values are consistent. For example, beginner and beginner should be standardized depending on the capitalization of letters. This data set appeared consistent, but the str.lower, str.capitalized method could be applied to make sure all entries are uniform if inconsistencies were present. But inconsistencies weren't present, so we didn't have data type conversions. Certain columns such as dates or numerical values may be incorrectly formatted as strings. For example, the Burns calories column was saved as text with converted to numerical type. Also, outlier detection, outliers or extreme values can distort analysis. Visual tools like box plots can help identify unusually high or low values that may not be realistic or could be errors. After cleansing, the data becomes structured, reliable, and ready for meaningful analysis. Now, moving on to data analysis. EDA involves investigating the dataset to uncover patterns, spot anomalies, and form hypotheses. Here are the typical steps and analysis we perform. First, we use descriptive statistics. Basic statistics such as mean, median, minimum, and maximum values give insights into the data's range and central tendency. For example, DF that described. For this dataset, calories burned had a mean of 230 with a range from 130 to 355, which indicates the variability in calorie burning across different exercises. Frequency counts for categorical variables. Understanding the distribution of categorical variables like difficulty level provides insights into exercise types. Here we counted exercises across beginner, here, beginner, intermediate, and advanced levels. Now, visualizing data at distributions. Histograms. A histogram of calories burned shows how expenditure varies across exercises, revealing that most exercises burn between 180 to 280 calories. As shown here. Count plots, we created a count plot for difficulty level to see which difficulty levels were most common. This kind of plot shows the balance between levels, which can help in designing workouts for different skill levels. Exploding and counting multi-value columns. Columns like target muscle group, here, columns, here, target muscle group, contain multiple values separated by commas. By exploding these entries, we split them into individual values to count how often each muscle group is targeted. The analysis which muscle groups were most commonly targeted, showing a focus on areas like, uh, say, glute core, shoulders, and so on. Correlations between numeric variables. Understanding relationships between numerical columns like sets, reps, and calories burned can help answer questions such as whether more sets and reps lead to a higher calorie expenditure. A correlation matrix, which can be visualized using a heat map, shows these relations. So here is the data cleansing process. Also, oh wait, I did put df.wrap duplicates for the earlier discussion about data cleansing, but we don't have issues in our data set. Still, in order to show you this, here is the EDA, the distribution of calories burned by exercises. Calories burned by exercise per 30 minutes. Exercises by difficulty level and top 10 targets across exercises. Now, let's talk about the benefits of EDA and data cleansing. By performing EDA and data cleansing, we gain a well-rounded understanding of the dataset, ensuring it's ready for further analysis. EDA allows us to see the potential for patterns or relationships, while data cleansing ensures that these findings are reliable and not skewed by data issues. Together, these steps provide a strong foundation for meaningful analysis and insights.
Good day, my name is Lance Gerson F. Baguio, and this is the modeling section for our data science project. So first, we have an import from sklearn, or most commonly known as scikit library. In the metrics module, we imported the silhouette score. Then we created a data frame with these columns and transformed them from strings to integers. Then we created an elbow method to find the most optimal number of clusters. So I tried a few of them and I found 3 and 4 to be the best. But this was created by my group mates, so I left it as is because this was 3 when I saw it. Then they created cluster, a scatter plot, I think, to showcase the clusters. So below here's the cluster 0, which has the lowest calories burned based on reps. And then cluster 2 and then cluster 1. Then we can see the silhouette score. Now let's move on to linear regression model, which I think isn't in the requirements, but I didn't saw it when I made this. So we first created our feature variables and feature variables and target variables, so we can ignore these columns and just imagine that X contains steps, reps, and clusters, because these columns are dropped except for these 3. Then we use this regression models with hyperparameters to get the highest accuracy when predicting the relationship of these variables. So here we created this cell code to create a report to find out which one has the best performance for our data set. So as you can see, we have linear regression, k-neighbor regressor, decision tree regressor, random forest, XGB, and gradient boost. But as you can see here, the best model from here is linear regression. So here we also made a graph to visualize the performance of this regression models. So for R squared, linear regression is the highest, and for the mean absolute error, I think the highest should be those that creates a lot of errors. So the lowest should be the best here. So as you can see, linear regression is the one that's at first. Same here, same with this. So now we tried using linear regression model for our now we're trying to use this linear regression model for sampling targets. So here we tried to get a few sample data from our data set and predicting its calories burned. So here, this is the data set that was the column that was taken from our data set. So this is the actual burns calories, and this is our estimated calories burned, which isn't on the she is a bit off the mark. So here we can ignore this because this is recycled code. Can focus here because we created a scatter plot to see the relationship between our the colors burned from the sets, reps, and clusters. So if this plots or points follow along this line here, it should indicate that it has positive or a perfect correlation with each other. So we got 0.67, and from the Wiley book, getting anything from R.5 is a moderate positive linear relationship. So now we're trying to use it for a new data, new set of data. So here we created new data frame that has sets, reps, and clusters, which is our target variables. So can use this to predict new data. So here if the that particular data has 4 sets, 15 reps, and it's inside the second cluster, then the calories burnt within 30 minutes should be 369. So I did this again so that you can get the can use validation and this R1 score using the random forest model, which I'm more familiar with. So here we created bins to label the burst calories from low, medium, and high. So down here, we are creating a report for the precision score, goal score, and the F1 score. So as you can see, some of them aren't showing any changes or showing any value. Like here in the high label or high calories burnt label. And here, even though it says that it's one, this is very dubious because it indicates that there's probably something wrong, even though it's as a perfect prediction score. So here I tried using a heat map to validate using this model from our original dataset. So here in cluster 0, we have a lot of variety of predictions. It has high, low, medium, but for cluster 1 and 2, they aren't doing that well in predicting or classifying the target variables. So I would suggest that sticking with cluster 0, which may bring some good results. That's all for me. Thank you for listening.